Hey everyone, we are back again with another video brought to you by Carnegie Mellon University, picoCTF, and the NSA Gen Cyber Program. Today's video is going to be covering the magnificent shell. And no, even though this video is named Seashells, we are not talking about Sally selling seashells by the seashore. We are talking about the terminal, which exists on every machine pretty much and allows you to do some pretty nifty things. So what we will cover in this video is what the shell is and why it's important, as well as how you access it, what makes the picoCTF shell so special, and how it interacts with the problem space, as well as how the shell can be used to solve problems and make our lives easier. So what is the shell? First and foremost, it is the hacker mascot. Now, what does that even mean? That means if you've ever watched a show or a movie where they're like, watch out, they're in the mainframe. And, there's all of this hectic energy flying around and everybody's getting all excited. And you see these random scripts running up and down the screen and all this stuff popping up. What they're utilizing in that moment, 9 times out of 10, is the shell. The shell is what is getting them to the mainframe or outputting the data that they need to see. Even most of the time, it's what's cracking the passwords and counting things down. It's essentially the command and control center of the entire operation. So it's a space for users to interact with the operating system directly. So normally, like say if you want to open Google Chrome, right? That's your web browser. That's what you want to open. Typically, you find the application, you see the little icon that says Google Chrome, and you click on it, and then boom, Chrome pops up. So what's happening there is something happening under the hood there. And what's happening under the hood is the shell is typically spawning this, what we call a process. And so there is a way for you to be able to spawn or open applications without ever having to click the icon. You could do it directly from the shell. It's this designated space where you can utilize tools and materials to build, create, and explore. It is an almost bottomless pit of knowledge. I personally do not know everything there is to know about the shell, and I don't know if I ever met somebody who even claims to know everything that there is to know about the shell. But there are so many tips and tricks out there as to how you can utilize it and how it can help you move forward in your technical spaces. Since that is where it is utilized, mostly in technical spaces, you see it a lot within cybersecurity and networks and computer science specifically, because we need to do a lot of things that interact directly, and it saves you a lot of time if you don't have to just open everything up, especially if you need to run programs or communicate with something directly. You can do almost anything from the shell. As I kind of mentioned earlier, you can open and download applications. You can communicate directly with the web. You can create, open, and delete files, as well as view the contents without ever actually opening the file. You can see who owns the file, a lot of stuff with files. You can also run programs. So if you're learning how to program, it is always a good idea to try to learn how to do it within the terminal. While IEDs, which are development environments, are very user friendly, learning how to do it within the shell or the terminal is very, very useful. So let's go ahead and hop directly in to some practice problems. So I'm already logged in to picoCTF, where we've made our accounts. We've ended up at this practice problem scenario. And we're just going to go ahead and dive directly in. So we see we have these problem spaces where there's web exploitation, crypto, reverse engineering, forensics, general skills, binary exploits, and uncategorized. We personally are going to focus on general skills so we can familiarize ourselves with the shell. We have videos that do cover problems like obedient cat, Python wrangling, nice netcat, tab attack. I want to say like Let's Warmed Up as well has been covered, and there are a lot of write-ups on Pico problems, so you can find walkthroughs of these as well. But today I'm going to focus on Maggie Carp ground mission. I really hope I did not pronounce that wrong, but that's what we're going with. So when we look at this problem, what do we see? We see we're going to have to launch an instance. So it's not running. That's the first thing I noticed. So we were probably going to have to press this button at some point. And then we see the description says, do you know how to move between directories and read files in the shell? Start the container, SSH into it, and then ls once connected to begin. Log in via SSH as CTF player with your password. This. Additional details will be available after launching the challenge instance. Our hints? Honestly, this depends on how you like to solve problems. I like to get the hints out of the way right at the beginning. Some people like to go for it on their own and then see if they get stuck and then they need a hint. To me, the hints give me a good baseline as to where to start. So we're going to know that we're going to need a bash cheat sheet more than likely. So since that's the case, since we're already here, we're going to utilize another Pico resource, which is our Pico primer. So our Pico primer, we see that there is a whole section on the shell. And I'm actually going to take this one back because I already have the Pico primer open. And so I want to keep this also open in another tab. So if you are running through this by yourself, a way to be able to open this in another tab is we go from learn and then you right click and then you could say open in new tab and it'll open right next to it. So now you have them side by side and you don't have to lose all of your Pico progress. And so we see the shell, as I told you earlier, this is the symbol of the hacker. Hacker life is in the shell. um, so this will give us some really good things. We see that we have some walkthroughs, what the $ means. This is a great place to start for what the shell is. You have wget. We see a lot of commands. I'm kind of just scrolling through this really, really fast. And then it takes you like through stepping through. We see, okay, we have like date. Oh, we see that cat is how you can see the contents of a file. We're installing an application. I'm just kind of scrolling through here. Oh, now we see a cheat sheet. So we can open that in a new tab. And when we view our cheat sheet, we can see now what command did it tell us to stay on the lookout for. But this is before we even started the problem. We have SSH and LS. So we see that LS lists the directory of the contents. There is an ls-la, which listed the directory contents, including hidden files. So that may be something that we need to keep in our back pocket, that files can be hidden. So that means if you just ls, you just list it, you won't see it. Cat, as we kind of saw in the primer, that's going to output the contents of the file. Let's see, what else do we have in here that might be useful? Oh, we see that we have permissions, processes. It also tells you a lot about like the tab key, arrow key. So like that's more so getting output. So now we know, okay, ls is going to list the directory contents. So now let's go ahead and launch our instance. We know what ls does, but we did not actually see this SSH command. So we can ask, like any good hacker does, we can ask Google, what does SSH do? SSH is often used to log in and perform operations on remote computers, but it may also be used for data transferring. Provides secure encrypted connection between two hosts over an insecure network. So basically that means you're going to log into one computer from another computer without ever having to physically access the other computer. SSH comes in handy for a lot of things and very, very handy. It's used a few times within problems. So let's go ahead and start this instance. It's starting. So now we see that the instance is started and they have so generously provided us the SSH command that we will need to be using. So now, while you could attempt to do this from your own terminal and your own machine, why work harder when you can work smarter? So what we're going to do is just go ahead and utilize the Pico web shell. So that's whenever you click on this nice little area here that says web shell. Now you just need to enter your username, enter your password, and when you log in, it says, welcome to the web shell. You will see this here. It tells you your name, -picoCTF at the web shell. Now, when we look at our problem, if we look at the SSH command, we can literally highlight, right-click, copy. You can do like the copying and pasting shortcuts within the shell. Personally, I've used it a lot of times where like the copy and paste just doesn't work. So I tend to do just the manual kind of longer step of copy and pasting. So then we can paste that directly into the terminal. And now it says, are you sure you want to connect? Now you see a lot of things here. It tells you the host, that there's a fingerprint, which this is just like a cybersecurity thing that's supposed to basically tell you that you're having a secure channel. This key is not known by any other name, so that kind of means it, but this is just like, are you sure that you're connecting to the right thing? Yes, you are. And then so now that's permanently added, which you may never even need to go back to it, so that may not matter to you. To your list of known hosts, and now it's asking for the password, so we can go back to the problem and we can copy this password and paste the password into our terminal. Now, as you may have noticed, the password did not show up. That is by design. Even when you typed in your password in the beginning, the password did not show up. That's typical for SSH and shells. If you are putting in the password, you will not see any characters. And that's just how it goes. It's a security thing. I'm sure it has other meanings and purposes, but that's not really what we're focused on right now. So we see that we are now the CTF player at Pico Challenge, as opposed to earlier when we were our username at picoCTF web shell. So now we can think back to the problem, or we can open it again. And we saw that the command that they wanted us to focus on was ls. So when we went to our cheat sheet, we saw that ls lists the directory contents. When we go back here, we can just type ls. And now we see that there is a 1 of 3 flag.txt and an instructions to 2 of 3.txt. So now that we see that, we can go back. How do we see what this 1 of 3 flag is? We remember that there was this lovely command, cat, that outputs the content of a file. So we can cat 1 of, and the good thing about a terminal is that it loves to autocomplete for you. So if you just hit tab, it'll autocomplete the entire file name for you. We can enter, and now we see we have 1/3 of a flag. That's nice. Okay. So what if we cat the next file? To go next, go to the root of all things, more succinctly, /. So now we're wondering, okay, it wants us to go to the root of all things. What does root mean? So we can go back to Googling root. What is the command line root? So it is the highest level in a directory hierarchy and includes all under directories from it. Okay. We could say, how do we access the root directory? It's located in the home folder. All right, that might be interesting. Something else that might be interesting is to know where we are. So if we look for Linux command to list current directory. So we have ls, which is not really what we want. We want our path to show our current path. So the pwd command to write the standard output of the full path name from the root directory. So that is probably going to be very helpful for us multiple times. So if we hit pwd, we see that we are in home CTF player / drop-in. So if we want to change directories, we see that if we go back to our command line cheat sheet that we have cd, which is change directories. We also see pwd up here, the display the path of working directory, but I want to show y'all how You can also use Google to find this if we're not using this lovely cheat sheet. So you can cd ... and that takes you back one. And then we can pwd again. Okay, and we can cd ... go back another, pwd, cd ... go back another, pwd. So now we see that we're back in slash. When we look up, it says go to the root of all things, more succinctly slash. Now that is the only thing that's left in our directory. So we know we've navigated all the way back to where we need to go. So we can now list the contents here, and we see 2 of 3.txt. So we can cat 2 of 3.txt, and now we see we have another third of the flag, and we have the same instructions to 3. So we can cat instructions to 3. Lastly, go to the home directory, more succinctly, tilde. So if we just hit cd and pwd, we see that we ended up in home/ctf player. Now, what happened there? I went through it kind of fast. When you just cd with nothing else there, when you try to change directory with no other input, it takes you to your home directory, which is technically where the tilde is. There is another way to navigate to it, but if we ls, then we see flag 3 of 3.txt. If you want, another way you could do it is cd tilde slash, I think, and then you're still in the same directory. It took you still to the home directory. So you could cd tilde slash, or you could just do cd without anything else. Now, if we cat 3 of 3, now this is once again cat, and then I type the 3 and hit the tab. Then we see the last part of the flag. So now we can copy these 3 pieces, copy, paste, and then there's our 2 of 3. Is that not going to work out how I want to? Not at all. So I will be copying and pasting this in a separate document off screen, just because it will not, I'm sure there's a way for me to do this better. You can also push these into another file, combine the files. There are lots of ways to do this that don't involve copy and paste, but for simplicity purposes, we are going to be copy and pasting. Boop, boop. So now we have the full flag. And whenever we come here, we click on the problem, it loads, we scroll down, we paste the flag, we submit. Hooray, we've earned 30 points, and it kicked us out. As you see, the connection closed because now the problem has been solved. And then if you want to exit this, you can either type, I think, if you want to exit this, you can just click the X and it automatically closes you out of the web shell. And we have now solved a lovely picoCTF problem. So now what did we learn? We learned the shell is not as scary as it looks. It can be a useful tool in all technical disciplines, and especially within picoCTF. It can be used to view and edit code, as well as a host of other things. The shell commands that we used were SSH, ls, which is used to list the directory contents, pwd, which shows the path directory that you are currently in, and cat to show the contents of the file. Our next steps are to dive deeper into utilizing the shell with more general skills problems. You can find out how to utilize file permissions, see hidden files, and more about the wonderful world of shells. Once again, the shells as in the terminal and not seashells. You can check out the Pico primer to find further information about the shell. You can move into more advanced problems that utilize the shell, like reverse engineering and binary analysis, as well as you can start playing around actually running code within the shell, like Python. And that is all we have for today. I wish you the best of luck in all your future endeavors, and I will see you next time.